Hey. Today, looking at +1 on Leetcode, and this is a Python exercise. Yeah, this is Python, that's right. Just resetting here. Yeah, back in Leetcode. So, looking at the description, you're given a large integer represented as an integer array digits, where each digit index I is the ith digit of the integer. Digits are ordered from most significant to least significant and left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. So you're going to be given a multi-digit number in list form in Python, and the task is to increment that multi-digit integer by 1 and return it in list form. Looking at example down here, see the list is digits equals 1, 2, 3, and then the output is 1, 2, 4. So we have a multi-digit number 1, 2, 3 in list form, and we're going to increment that and then return it as a list form as 1, 2, 4, as you see here. Look at the other couple of examples down below. Look at example 2 and example 3. Example 2, digits 4, 3, 2, 1 becomes 4, 3, 2, 2, incremented. And here's a good example as well. 9 by itself becomes 1, 0. So of course 9, after 9 comes 10. You got to put it in list form as 1, 0. So yeah, taking an integer list and a list of integers, incrementing the multi-digit by 1 and returning that result. So really the strategy with this one that I came up with, and I think this is a pretty obvious one that anybody would come up with, is to take your list of digits, convert it to an actual multi-digit integer, increment by 1, and then you get your result, and then you convert that result back to list form somehow, and the somehow is going to be shown to you as I do what I do. Really, it's going to be by powers of 10. Actually, well, powers of 10 will be used. Well, you're going to take the list, to convert the list to a multi-digit integer. You're going to use powers of 10. But I am going to erase this, and we're going to do the bulk of this stuff in PyCharm. And I guess I'll grab this, drop it into PyCharm as well. Just so y'all can keep your eyes on the prize up here as far as like what is being done. Hopefully this ain't too much obscure what I'm trying to do. All right. And let's get a test case in here. Yep, dropping that test case. And so let me show you a little bit about what my strategy is going to be here. I'm going to take the list, convert it into a multi-digit integer. How am I going to do that? I'm going to multiply by powers of 10. And how do I get the powers of 10? I'm going to use the length of the list as a guide. Well, let's frame it like this. Take a look at 1, 2, 3, and of course it's going to turn into 123. Looking at the number 123, you could break that down into 1 times 10 squared equaling 100, and it's 2 times 10 to the first equaling 20. Then you have 3 times 10 to the 0 power. Anything to the 0 power equals 1, so it's really going to be 3 times 1 is 3. Let's add all those up. 100 plus 20 plus 3, of course, equals 123. There is your algorithm, my friends, where we will get the length of the list minus 1 and then use descending powers of 10, I guess you could say, because the length of this is 3. The length of the list is 3. Your exponents of 10 are going to start with 2 as you go left to right. I could even write it like this. Like, you look at 123, the 1 will use 10 to the 2, the 2 will use 10 to the 1, and the 3 will use 10 to the 0. You see it's descending going left to right. So the tactic is going to be to get the length of the list minus 1, and then use descending powers of 10, where the first digit will be 10 to the length minus 1, the second will be 10 to the length minus 2, and so on, going down to and equaling 0. So there's an explanation of the algorithm. So now let's put this into practice. Clear it out. If you need to check it out again, obviously you can rewind. Be kind, rewind. So they used to say back in the VHS days, for those who are, what, 30, 40 plus maybe, 35 plus. It's, time is passing. All right, so as I start this, I'm going to create an integer to hold the multi-digit integer. I'm going to call it whole, not while, and make it equal to 0. Then I'm going to set up my exponent variable, because I need to use a variable to hold my powers of 10 exponent. And I guess I'll call it this, exp, and it'll be the length, of my input. Digits is the input list. So I'm going to get the length of that list minus 1, as I was saying before when I showed you the write-up demonstration of the algorithm. Yes. Got to clear my throat this morning. Okay. And then I'm going to be doing a while loop, so I'm going to have an integer I equaling 0 as an iteration variable, because I'm going to iterate forwards through my list of numbers as I go. And now I'm going to create a while loop, and I'm going to say while my exponent variable is greater than or equal to 0, because as I was saying before, the exponentiation goes backwards from, in this example, it's going from 2 down to 0. So while it's greater than or equal to 0, my exponent, I'm going to do what I'm doing. And what I'm going to do is I'll explain this soon. All right, I'll explain this now. What I am doing here is, and actually this is right. let's look at the right side first. Digits index I times 10 to the whatever. So here I'm getting an element from my list of numbers. And for each element, I'm going to multiply it by a power of 10. Here it's going to be, and this is exponentiation in Python. Let's look at the case of this number. Let's look at the case of the first iteration. Digits would be 1, the number 1 right here, and then this would be 10 squared. So it would be 1 times 10 squared equaling 100. So in my first iteration, that's what it's going to be for this test case. And that 100 is going to be added to whole. So after that one iteration, whole will be equal to 100. And then as I iterate next, it'll be 2 times 10 to the 1, which will be 20. 100 plus 20 equals 120. On the next turn, it'll be 3 to give you 123. So that is how it works. Element of the number list times 10 to whatever power you're on right now. All right, back to the codings. All right, so once I've added that digit to my whole, or not that digit, once I've added that quantity to my whole, I am going to decrement my exponent, because the exponents go down as I move forward, and I'm going to move I up, increment I, because I'm going to move forward through my list. And once that's it for the while loop. Once I'm done with the while loop, I have my whole number, my multi-digit number. My multi-digit number is going to be stored in whole. Now remember, the idea here is to increment my large integer by 1. So I've got my multi-digit integer done. I'm going to increment it by 1. All right, so now I've done that operation. In the case of the test case, 1, 2, 3 is now 1, 2, 4. Now I've got to take the 1, 2, 4 and turn it back into integer list form. And it's a fairly simple process. I'm going to create a list to hold my my splitting, and I'll do the algorithm for taking a multi-digit number and splitting it into its digits. And here's how it goes. Yeah, that is the algorithm. So this algorithm is going to split whole into its constituent digits, if that's the right term. Whole is 124 to begin. And so what I do here is, when you modulo 10, you get the last digit of a multi-digit number, or any number, really, any whole number. So when I do modulo 10 on 124, it gives me a 4. I put that 4 into my list, and the new digits list. So let's look at what happens. You take the 4, put it into this list, you append it, and it becomes the first element. And then I do a division by 10. When you divide a whole number by 10, you get rid of the number in the ones place, the last digit. So I get rid of it. Then I loop back around and I do modulo 10 on 12, which will give me a 2. I append that to my list. There's the next element. Then I do divide by 10. Kill it. Then I come back around with 1. 1 modulo 10 is 1. Append it. And there I have my multi-digit, my multi-digit integer turned into a integer list. But of course, notice it's backwards because of how I did this looping. It's backwards. I just need to reverse it. So, no big deal. Reversing it ain't that hard in Python. So I'll do that. And how I do that? Well, I'll just do it in the return because I don't need to do anything else. All I'm doing is reversing it and then returning it. So I'll do that all on one line. One line. There you go. Is that handy slicing syntax for taking an iterable, I guess you could say, and reversing it? That's how you can do it. There's some other ways, but I could call reverse or reversed or whatever, but this works. And it's a conversation piece, right? So now let's, this is done. Let's take this and use a test case or test cases on it. Yeah, we can use 123. Dub. Should get a 124 in list form. So I'll flash the light. There we go. Awesome stuff. 123 becomes 124. Let's throw another test case in here. Yeah, let's do this one, the 9 to 10, because it's a telling one. Not that. Plus 1, 9 should become 1, 0. And we have the magic. The magic has happened. Out effing standing. Yes. Okay. I think this is ready to go, folks. Let's copy it. Drop it in. Drop it in. What is that? So much going on. All kind of codings. All right. Indentation. I'll probably get an indentation issue error or whatever with this. Oh well. Yeah, this code can definitely be condensed, of course, but this is what I'm going with for now. As I always say, y'all can handle that. Make it better, make it plain. All right, so it passes those initial tests. Let's submit. See what we get. Alrighty, accepted. Good. And yeah, efficiency be damned. You guys can handle the efficiency part. See what you can do, let me know. But here's your code. I do like this one. This is kind of, especially on the beginner side, there's a little bit of trickery here, but crafting algorithms like this is kind of fun. In fact, it's super fun. But yeah, with that, got my passing grade. I'm out of here, and you're out of here. Until next time, see y'all later.